Thus, this PPF shows the opportunity cost of one good in terms of the other, and this is also measured by the slope of the PPF. Now, why does the shape of PPF in the two examples varies? If you remember, in the first example, the slope was constant, and in the second example, which we discussed today, the slope varies across different points, and in this particular case, the slope is convex. Now, why should that be? To know that, first we need to understand what does the slope of the PPF measures. The slope measures the change in the number of computers, that is the change in y, since computer is on the y-axis on the graph, so that is the change in y, due to change in the number of cars. Here car is on x-axis. So traditional formula for using slope is given here, which is change in y divided by change in x, and this is the same way in which we calculate the slope of the PPF. So in this particular graph, the first one, you see that we have a convex PPF. Now let's check out what is the slope of this PPF. So if we move from A to B, what is the slope? The slope would be the change in y, that is the change in computer here, which is 2200 minus 2000, that is equals to 200, divided by the change in cars, which is 700 minus 600, that is equals to 100. So 200 divided by 100, that is equals to 2. So at moving from point A to B, the slope of the PPF is 2. Now let's check out the slope at another point. So if you calculate the slope between point B and point E, so at point B, the country produces 2000 computers and 700 cars. At point E, the country produces say 400 computers and 800, let's make it 900 cars. So I have taken the values arbitrary, but here if you see, now the slope between point B and point E, so the change in the number of computer would be 2000 minus 400, that would be 1600, divided by the change in the number of cars, which is 900 minus 700, that is equals to 200. So 1600 divided by 200, or that is equals to 8, is the slope between point B and point E. I would request all of you to draw this by your own and find out the slope. So you see, at between point A and B, the slope is 2, and between point B and E, the slope is 8. So moving down, the PPF increases the slope, and that is why we have a convex PPF here, because the slope continuously rises as we move along the PPF. As opposed to that, if you look at the second graph, which shows a straight line PPF, so here, moving from the second point to the third point, the change in the number of wheat and divided by the change in the number of computer will give us the slope between the second and the third point, and that will also be true for any point for the slope between the third point and the fourth point on the PPF. So in this PPF, if you calculate, then you will find that at each and every point on this PPF, the slope is constantly same, and here the slope would be always 100. And since the slope doesn't change across the points, that is why we have a straight line as opposed to the left hand side figure where the slope constantly rises as we move down the PPF. Thus, the slope of the PPF decides on the shape of the PPF. Depending upon the slope of the PPF, we get different shape of PPF. The slope of the PPF is exactly same as the opportunity cost. The slope between point A and B is 2. If you go back to the previous graph, you will find it, and which means in order to produce one extra car, the production of computer reduces by 2, which is exactly what we call opportunity cost. So both the opportunity cost and the slope between point A and B is 2. So in your exams, if I say that the slope of the PPF is 2, which is exactly same as the opportunity cost, or rather than mentioning the slope, if I rather say that the opportunity cost of moving from point A to point B is 2, you should also understand that the slope of the PPF is also 2. Next we see how PPF and economic growth is related. Economic growth can take place because of two reasons. The first one is the rise in the labor, and the second reason is rise in labor productivity. In both of the cases, the economy experiences a rise in its growth. So in our example, if you remember, the total number of labor was fixed at 5,000. So we cannot produce at point C as it will require hours more than 5,000 laborers. However, if the labor number rises and gets doubled to 10,000 labor hours, in that case we would be surely producing more cars and computers using those laborers. So a rise in the labor resource will shift the PPF in a parallel manner, and the PPF would look something like this. So the arrow represents the shift in the PPF. Here the PPF shifts parallelly because since the labor amount rises, we can use that those labor to produce more computers and cars. So here we are again assuming that we increase the production of both computers and cars as the labor rises. And since the labor rises and we are producing more of both the goods, the economic growth takes place. Another way in which the economic growth can occur is due to the rise in labor productivity. So we can produce more of both cars and computers using the same labor resource. Here, rise in productivity means that the same labor would be producing more. So for example, if previously we were making one computer using 100 laborers, now since the labor are becoming more productivity, we would be producing one computer but using 50 labor only. So the labor requirement gets half because the labor productivity rises. So if labor becomes productive in both of the sectors, in that case, like before, there will be a parallel outward shift of the PPF. But if labor becomes productive only in computer industry, the PPF will rotate towards that sector and will produce more computers. But since the labor is same for the car industry, the number of cars will remain unchanged. The opposite will occur if labor becomes more productive only in car industry. The graph here depicts the scenario that I just discussed. So as you can see that with additional resources or with an improvement in technology in the computer industry, it might be the case that the labor are now well trained to produce more computers efficiently. So in that case, using the same number of labor, we would be producing more computers. But since labor becoming more productive only in computer industry doesn't affect the labors in the car industry, so the amount of car that we were producing will be the same, but the amount of computers now we producing would be rising, and that is why the PPF would rotate towards computer sector. The opposite will occur if the labor are educated more in terms of making cars. In that case, the computer production would not change, but the car production will rise and PPF would rotate towards the car industry. So that is how the PPF can illustrate the concept of efficiency, trade-off, opportunity cost and economic growth. So in your exams, you would be expecting questions from any of these topics, or maybe there can be questions from 2 or 3 of the topics as well. So in each of the cases, you are required to study the graphs very carefully and make sure you understand the topic clearly. That is the end of today's lecture. Thank you for watching.